In this video, we're going to be using the determinants that we were calculating in the first video to find the area of triangles and to solve systems of equations. So let's go ahead and just jump into an example. It says find the area of a triangle with the points -2, 8, 4, 12, and 1, 0. So what you could do is plot them on a graph, try to use the distance formula and find the length of the base and the length of the height, but that makes it very complicated. There's a lot of calculations there. Instead, what we can do is use determinants and the points to calculate the area. So what we have here is a nice little formula. Area equals plus or minus 1/2, and I'll explain that in a minute. And then we're going to do a 3 by 3 matrix because we have 3 points. So we're going to include all the x's in the first column, and then all the y's in the second column, making sure they go in the right order. And then the last column is always going to be the number 1 because there's only 2 letters or 2 numbers in a point, and so we have to make it a square matrix in order to be a 3 by 3, and so 1s won't affect our answers, therefore we can keep them nice and simple. Okay, so the ordered pairs always go first, and then 1s in the last column. So we're just going to go ahead and start this by plugging in what we know. We know we have a plus or minus 1/2, and then we're going to fill in all the x's and all the y's. So I'll do all the x's in green, -2, 4, and 1, and then we'll do all the y's in red, so 8, 12, and 0, making sure that our x's and y's match up to the right points. And then the last column in blue, all 1s. And now it's just like our first video, we're going to go ahead and find the determinants. So I'm going to rewrite the first column and the second column. 8, 12, and 0. And then we're just going to go ahead and start calculating our determinants. So remember the first diagonal all the way from top to bottom. Okay. And if I multiply those out, I get -24 plus 8 plus 1 times 4 times 0 is 0. And that's going to get us -16. And then I could do the same thing going the other direction, remember from bottom to top. There's the first diagonal, second, and third. And when I multiply those out, I get 12 plus 0 plus 32. So add that, we get 44. Be really careful with those zeros. A lot of people forget when you multiply by 0, you get 0. And then we always said we subtract bottom, minus the top, and if we do that we get -60. Now the problem with this is that we can't have a negative determinant. We can't have a negative area in this case, so that's where the plus or minus 1/2 comes in. So we've got that because our calculation is negative, we're going to use -1/2 times -60, and that's going to get us positive 30. So our area is going to be 30 units squared, and then we're done. So it may take a little bit of multiplication and addition more than if you were to use the distance formula, but you don't have to graph it on a grid, and as long as you can multiply and add together, the determinant's a pretty easy thing to calculate. So just be very careful that your area is always a positive number, and make sure that you're careful with your multiplication and addition, and always subtract bottom minus the top for the determinant. Now we can go ahead and use determinants to actually solve systems of equations, and that's what we're going to call Cramer's rule. There are 2 things you need to pay attention to when you're using Cramer's rule. The first is when you calculate your determinant, you need to tell if it's 0 or if it's another number. If it is 0, that means that you're either going to have a no solution answer or infinitely many solution answer. And at that point, I would suggest using elimination or substitution or something similar. If you get anything other than 0, then that means you're going to have one solution, and we can go ahead and continue with Cramer's rule. So we're just going to jump into an example and show you what Cramer's rule looks like. And before we can actually implement the process, we have to see what it looks like originally. We've got 2 equations of lines here. Normally I would have told you either graph them or use substitution or elimination, and now we're going to be showing you using matrices. When we are going from equations to the matrix form, we want to make sure we write a matrix equation. And to write equations in matrix form, we're going to start with what we call the coefficient matrix. And the coefficient matrix is just the numbers in front of your variables. In this case, because we have two variables, we're going to have a 2 by 2. So I'm going to start with my x's in the first column, so that's 5 and 3, and then my y's in the second column, similar to what we did in the triangle examples. Okay. Then after that, you're going to put your variables in a 2 by 1 matrix. So we'll have x first, then y. And then at the end is going to be the solutions to your system, also in a 2 by 1, 15 and negative 29. And the reason that we set it up in this format is because if I were to do matrix multiplication back in the last section, you always do row, then column. And if I do that each time, I'm going to get my equations to look exactly like I had originally. So it's transforming it from linear form to matrix form. All right. Now, to actually implement Cramer's rule, there's a couple things we have to calculate. The first thing is to find the determinant. And just like we did in the last video, you're going to take the numbers and work with the diagonals. So we're going to start by finding the determinant of our coefficient matrix. So that's 5, 3, negative 6, and 4. Remember, we do the first diagonal, that's 20 when we multiply, and then the second diagonal, that's negative 18. And we can go ahead and subtract those, bottom minus the top, and we get positive 38. So there's our determinant. We're going to use that twice. The second step is to find the determinant of x. So what this means is that we're going to take the coefficient matrix, but we're going to change the x column and put the solutions into the x spot. So instead of having 5 and 3, now we're going to have 15 and negative 29. Okay. And then we're going to keep the y's the same. So notice I took the x's here, or the solutions here, and plugged it into the x spot. And now we're going to calculate our determinant like normal. So we start with our multiplication. 15 times 4 is 60. And then we can do the other diagonal, negative 29 times negative 6, we get 174, and then subtract bottom minus the top. So 60 minus 174 is going to get us negative 114. And then we're also going to do the same thing, but this time with the y's. So we're going to have, I'll scroll back up. The determinant of the y values. So we're going to go back to our coefficient matrix. That's the original here. And this time we're going to take our solutions and we're going to plug them into the y column because we're talking about the y's here. So we're going to leave the x's alone back to the original, and then we're going to replace the y column with 15 and negative 29. So still doing a determinant. So if we do our diagonals, 5 times negative 29, that's negative 145. And then 3 times 15 gets us 45. Go ahead and subtract. Negative 145 minus 45. I'm going to get you negative 190. So now we have three determinants here. We have the original, we have the x, and we have the y. So now the last part of Cramer's rule is to get your x value. So to get the x, what we're going to do, let me get a different color here, is that we're going to take the d of x divided by the original determinant. So in this case, that would be the negative 114 divided by 38. And if we can do that, we get negative 3. So that means the x is negative 3. And do the same thing for the y's. Take the d of y over the original determinant, and that gets us negative 190 over 38. So notice the denominators are the same in both. So negative 190 divided by 38 gets us negative 5. So our final solution to this would be the ordered pair negative 3, negative 5. And you could always go ahead and plug those numbers back into the original equation and make sure they work. 5 times negative 3 minus 6 times negative 5 should get you 15. Same thing with the bottom. 3 times negative 3 plus 4 times negative 5 should get you negative 29. Okay? So it looks like a lot of work, but it's really just multiplication and subtraction. So just be really careful where you're setting up. And the d sub x and d sub y, those are the more commonly made errors. So make sure if it says d sub x, you're replacing the x column. If it's d sub y, you replace the y column. Okay? So I'd encourage you to try one more example here on your own. Remember, you want to make this into the coefficient matrix first so you know what you're working with. So let's do that here. Remember all my x's and all my y's, the letters you're solving for, C and D, and then your solutions at the end. And then you just want to go ahead and calculate the original determinant, d sub x and d sub y, and then set up your fractions. So if you have any questions on that example, let me know. And this same method could be used with 3 variables as well. So I'm only showing you 2 variable examples, but the 3 variables is the same exact thing, just with a 3 by 3 instead of a 2 by 2. So if you have questions on how to do that in class, of course, make sure you ask me and we can work through one together. That's it for today.